Hello, physics students. Today we're going to do a friction problem, not a fraction problem for once, a friction problem, where we are going to find the acceleration of a 20 kilogram crate being drug across the sidewalk by a guy at a 30-degree angle. His force applied is 90 newtons, and other than that, that's about all you know. And we're going to have to jump through all these hoops. There's about 5 steps in this, and I'll show you how to find the acceleration. So, now, the first thing that we're going to do is find these vector forces, which I will draw in hot pink here, right through here, and right up through here. And you got to think of everything as in terms of vectors. Now this is a new layer, so I'll be able to fade this off. If we're going to find this, I'm going to label this F sub x because it's the sideways motion of this, and this will be F sub y over here, F sub y. And just going to do these two little trig problems. So here's Fx, here's F of y, and that's going to be using f of x as the adjacent side. This is the hypotenuse. So cosine of 30 equals f of x over 90. And I would, of course, multiply there. And I would do 90 times the cosine of 30. And that would wind up being 77.9. So f of x is 77.9. And I am going to go back and stick that on layer, my original layer, 77.9 newtons. I'll go back to this, and we'll find f of y now, which is the opposite side over the hypotenuse, which is the sine. So sine of 30 equals f of y over 90. And we would, of course, multiply again, and that answer will be 45 newtons. These are all in newtons. And you can also remember the little trick to this is the side opposite of 30 is half the hypotenuse, which is an interesting little pre-calc twist in that. So this is 45 newtons. I'm drawing over my stick figure, but that'll be okay. So now we have that, and if I fade this layer out, you still should be able to see the answers there. So we'll go ahead and we'll fade those out, but you can now see that this up arrow is 45 and this is 77, and that's going to come into play. The next thing we're going to do is find out what the gravitational force of this thing is, which is the weight, or mass times gravity. And that's very, very simple. We'll just go ahead and go 20 times, and that's 20 kilograms, times 9.81 meters per second squared. And when that's all said and done, that's 196.2 newtons. 196.2. Yeah, I'll put that back on layer 1. So let's see. If I fade that off for a minute, and I put this, because this, I run out of real estate when I go doing this. That's 196.2 newtons. The next thing I want to do is find, and I'll put this back on this layer so we can see it, is to find this normal force. And remember, the normal force is the total force, the difference between the weight and any forces applied upwards to it. But we happen to have one here. We have one right here. 45 newtons going up, 196 going down. So the Fn force, or the normal force, is simply the force of G, force of gravity, or the weight, minus the F sub x, or I'm sorry, F sub y force right there that we found earlier. Right, like that. So, normal force equals 196.2 newtons minus 45 newtons. And when you do all that, that's 151.2 newtons. Now you might be wondering, why do we need to know this? And the reason why is because when we do our coefficient of friction problem, I'm just going to write that on there. When we do our coefficient of friction problem here in a minute, we're going to need to know this normal force because that's the denominator of that equation. Next thing we're going to do is find this force of kinetic friction. This is the force that's holding this crate back as this kid drags it. Now remember, he's dragging it with a sideways force of 77.9. We have to figure out what this is, because if he's not breaking this or beating this, he's not moving it. So he might not even be able to move this thing, so we'll see. But if we're going to do this, and we know that the problem also gives you, although I forgot to write it, that mu sub k is equal to 0.5, then we come down and we use our coefficient of kinetic friction equals, I think I'll be able to just put it on this layer this time, equals the F of k over the normal force. That's the equation. And we can plug it in right now and find F of k. So this would be 0.5 equals F sub k, which we don't know yet, over the normal force, which we found earlier, which is 151.2 newtons. 151.2 newtons. And of course, to solve for F of k, we multiply 151.2 newtons times 0.5, which is just half of 151.2, and that comes out to be 75.6 newtons. We'll come up here and put that in like a pink color, something this really sticks out, 75.6 newtons. So now let's look and see what we got here. We have, I'll put this on a new layer so I can erase it. We have 77.9 newtons going this way. We have 75.6 newtons of friction pulling back on this way. So we can see that the kid is actually pulling it sideways. It wins. And if we subtract the two, 77.9 newtons minus 75.6 newtons, we get 2.3 newtons going this direction. So the kid is winning. He's beating friction and dragging it slowly across the concrete, I'm sure with some difficulty. This is now the force, the sideways force. So if we go back to Newton's second law, which is ma, we're almost done with this problem now. Force equals mass times acceleration. Remember, our goal here was to find the acceleration. So the force of the kid pulling on the books is 2.3 newtons. The mass, 20 kilograms, that's given in the original problem, times acceleration a. So this turns into a regular little problem here. We divide both sides by 20. That, of course, cancels. And we get acceleration equal to 0.115 meters per second squared. And this problem is should be looked at again. I don't know if people get this the first time they see it. As you can see, if I put all this work on the same thing, there is lots and lots of steps to this problem. But it ends up in a nice little easy Newton's second law problem. And thanks for watching, and I'll see you tomorrow.